Super heavy tank. This extreme category represented the pinnacle of armored protection and firepower sacrificing mobility for near invulnerability against contemporary anti-tank weapons. Germany's Panzerkampfwagen 8 Maus remains the heaviest fully enclosed armored fighting vehicle ever built, weighing 188 metric tons. Measuring 10.2 meters long, with armor reaching 220 millimeters on the hull front and turret, the Maus mounted a 128 millimeter KWK-44 main gun with coaxial 75 millimeter gun. Only two prototypes were completed by July 1944 before the program was canceled. The American T-28 Super Heavy Tank, also designated T-95 gun, motor carriage was developed to assault the Siegfried Line fortifications. Weighing 95 metric tons with 305 millimeter frontal armor, the T-28 mounted a 105 millimeter T-5E1 gun in a fixed casemate. Using 4 tracks to distribute its enormous weight, the outer tracks could be removed for rail transport. Powered by a Ford GAF V8 gasoline engine, producing 500 horsepower, the T-28 achieved only 13 kilometers per hour. Two prototypes were completed in 1945, with the project terminated in 1947. Tankette. This minimalist armored vehicle represented the smallest and lightest category of tracked fighting vehicles, designed for reconnaissance machine gun support and infantry mobility. Weighing typically under 5 metric tons, Tankettes featured two-man crews in cramped open or partially enclosed hulls armed only with machine guns. Britain's Carden Loyd Mark VI, introduced in 1927, became the most influential Tankette design worldwide. Weighing 1.5 metric tons and powered by a 40-horsepower Ford Model T engine, the Mark VI achieved 40 kilometers per hour with a crew of 2 operating a single Vickers machine gun. Approximately 450 were produced between 1927 and 1935, exported to 16 countries and licensed for production globally. Italy's CV-33 derived directly from the Carden Loyd design, mounting twin 6.5 millimeter machine guns in a welded hull weighing 3.2 metric tons. Between 2000 and 2500, CV-33 and CV-35 variants were produced from 1933 through 1936, seeing combat in Ethiopia, Spain, and North Africa. The Soviet T-27 enlarged the Carden Loyd concept, producing over 3,200 units between 1931 and 1933. By World War II, Tankettes proved obsolete against modern anti-tank weapons, though the Carden Loyd design spawned the highly successful British Universal Carrier. Wheeled tank. This experimental category attempted to combine tank firepower and armor with wheeled vehicle road speed and range. Lacking tracks, wheeled tanks achieved higher speeds on roads with lower maintenance requirements but sacrificed cross-country mobility and obstacle crossing ability. American inventor J. Walter Christie pioneered convertible wheel track designs in the 1920s, allowing vehicles to run on wheels for road travel or tracks for combat. His M1928 and M1931 designs influenced Soviet BT tank series development, with the BT-5 and BT-7 capable of 62 kilometers per hour on wheels. The South African Reconnaissance, introduced in 1990, features 8-wheel drive, mounting a 76 millimeter gun in a rotating turret weighing 28 metric tons. Modern wheeled fighting vehicles, like the Italian Centauro and French AMX-10 RC, combine tank-level firepower with strategic mobility, though they remain vulnerable in rough terrain. The concept never achieved widespread adoption, as tracked vehicles proved more versatile in actual combat conditions despite higher mechanical complexity. Rocket artillery tank. This mobile fire support vehicle mounted multiple rocket launchers on armored chassis, delivering devastating saturation bombardments. The Soviet BM-13 Katyusha, introduced in 1939, became the most famous rocket artillery system, mounting 16 132 millimeter M13 rockets on truck chassis. Each rocket weighed 42 kilograms with an effective range of 8,740 meters. A battery of 4 BM-13 launchers could fire a salvo in 7 to 10 seconds, delivering 4.35 metric tons of explosives over 400,000 square meters. Approximately 10,000 Katyusha launchers of all variants were produced by war's end, mounted on various truck and tractor chassis. The American T-34 Calliope mounted 64.5-inch rockets above a Sherman tank turret, providing close fire support for armored formations, though only 800 were produced. Germany's Panzerwerfer 42 mounted 10 150 millimeter rockets on modified SD-KFZ 4 half-track chassis. Modern multiple rocket launch systems like the American M270 MLRS and Russian BM-30 Smerch continue the concept with GPS-guided rockets and ranges exceeding 70 kilometers. Combat engineer vehicle. This specialized support vehicle carried equipment for battlefield engineering tasks, including obstacle clearing, mine breaching, and demolition. Britain's Churchill AVRE converted Churchill tanks by replacing the main gun with a 290mm Petard spigot mortar, firing 40-pound demolition charges effective to 80 meters. The AVRE could mount fascines to fill ditches, bridges to span gaps, or explosive charges to breach fortifications. 180 Churchill AVREs participated in the Normandy invasion, clearing obstacles and defenses during beach assaults. The American M728 combat engineer vehicle, based on the M60 tank chassis, mounted a 165mm demolition gun alongside a retractable dozer blade and an A-frame crane for lifting obstacles. Modern CEVs like the IDF Puma and American M1 assault breacher vehicle combine mine-clearing line charges with bulldozer blades, providing engineers protected mobility in combat zones. These vehicles prove essential for reducing fortifications, clearing obstacles, and supporting advancing forces under fire. Reconnaissance tank. This category emphasized speed, stealth, and observation over firepower, designed to locate enemy positions and gather intelligence. Typically lighter than main battle tanks, reconnaissance tanks featured low profiles, excellent optics, and superior mobility, enabling rapid advances and withdrawals. The British Scorpion, introduced in 1972, weighing 8 metric tons, mounted a 76mm gun, achieving 80 kilometers per hour with excellent cross-country performance. The American M3 Stuart light tank served primarily in reconnaissance roles during World War II, weighing 12.7 metric tons with a 37mm gun and speed of 58 kilometers per hour. Over 13,000 M3 and M5 Stuart variants were produced, serving with American, British, and Soviet forces. Modern reconnaissance vehicles like the German Fennec and French VBL emphasize sensors and communications over armor, carrying thermal imaging, laser rangefinders, and data links, enabling network-centric warfare. Dedicated reconnaissance tanks largely disappeared after World War II, as main battle tanks assumed multiple roles, though specialized reconnaissance vehicles continue serving modern armies. Infantry fighting vehicle. This category bridges the gap between armored personnel carriers and light tanks, providing infantry with protected mobility and fire support. IFVs feature rotating turrets with autocannons and anti-tank missiles, allowing them to engage enemy armor while dismounting infantry for assault. The Soviet BMP-1, introduced in 1966, revolutionized mechanized warfare, mounting a 73mm gun and Sagar anti-tank missile while carrying 8 infantry. Weighing 13 metric tons with aluminum armor, the BMP-1 achieved 65 kilometers per hour and could swim at 7 kilometers per hour. Over 20,000 BMP-1s were produced and exported to over 40 countries. The American M2 Bradley, introduced in 1981, weighs 27.6 metric tons, mounting a 25mm Bushmaster cannon and TOW missiles, while carrying 6 infantry. Approximately 6,800 Bradleys were produced, serving through Gulf War, Iraq, and Afghanistan. Modern IFVs like the German Puma and Russian BMP-3 feature advanced sensors, active protection systems, and network integration, transforming infantry fighting from simple transport to integrated combined arms platforms. Armored command vehicle. This mobile headquarters provides protected workspace for commanders and staff, coordinating operations from forward positions. Based on tank chassis, command vehicles feature additional communications equipment, map tables, and workspace, replacing weapon systems. The German Panzerbefehlswagen command tank series converted Panzer III and IV tanks, removing main armament to install multiple radios and additional crew stations. The American ME-577 command post carrier, based on the M113 APC chassis, features a raised aluminum superstructure, providing standing headroom for 4 staff members with extensive communications gear. Over 4,600 M577s were produced, remaining in service through 2015. Modern command vehicles like the British Warrior Command integrate digital command systems, satellite communications, and networked data links, enabling real-time coordination. These vehicles prove essential for combined arms coordination, allowing commanders to maintain situational awareness while remaining mobile and protected, enabling responsive command and control on fluid battlefields. Ammunition carrier. This support vehicle resupplies combat vehicles with ammunition under fire, maintaining sustained operations. Based on tracked chassis, ammunition carriers feature protected cargo spaces and handling equipment for rapid resupply. The American M99 two-field artillery ammunition support vehicle carries 93 rounds plus propellant charges for M109 self-propelled howitzers, featuring an automated conveyor system for rapid transfer. Weighing 27 metric tons, the M992 achieves 61 kilometers per hour, keeping pace with artillery batteries. The German munition schlepper of Fahrgestell Panzerkampfwagen 4 carried ammunition for various artillery systems during World War II, though production remained limited. Modern ammunition carriers like the Russian TZM reload vehicle for BM-30 rocket systems feature hydraulic cranes and automated handling, enabling rapid resupply cycles. These specialized vehicles prove critical for sustained operations, as modern combat vehicles carry limited ammunition, requiring frequent resupply, especially for artillery systems with high rates of fire. Remote-controlled tank. This category includes unmanned vehicles operated by remote control or autonomous systems for reconnaissance, demolition, and assault roles. Germany's Goliath tracked mine, introduced in 1942, carried 60 kilograms of explosives guided by a three-wire cable system for demolishing obstacles and destroying bunkers. Measuring 1.5 meters long and weighing approximately 100 kilograms, the Goliath was mass-produced with over 7,500 built-though vulnerability during approach-limited effectiveness. The Soviet teletank program in the 1930s converted T-26 and BT tanks for radio control, deploying them during the Winter War, though technical limitations restricted adoption. Modern unmanned ground vehicles like the American Talon robot and Israeli Guardian patrol vehicle feature cameras, sensors, and weapons platforms operated remotely. The Russian Uran-9 unmanned combat vehicle weighs 10 metric tons, mounting a 30mm autocannon and anti-tank missiles, demonstrating increasing sophistication. Future developments promise fully autonomous tank systems with artificial intelligence, though human control remains essential for combat decisions. Armored bulldozer. This engineering vehicle combines bulldozer capabilities with armor protection, enabling terrain modification and obstacle clearing under fire. The Israeli D9 armored bulldozer adds 15 metric tons of armor to Caterpillar D9 bulldozers, protecting operators during urban combat and demolition operations. Weighing 62 metric tons with armor resistant to small arms and RPGs, the D9 has proven essential in Israeli operations, clearing explosives and obstacles in hostile areas. The Churchill AVRE could mount dozer blades for clearing obstacles during assault operations, providing engineers protected earth-moving capability. The American M9 Armored Combat Earthmover, specifically designed for military engineer tasks, weighs 15.7 metric tons, featuring a bowl for carrying earth and armor, protecting the operator. Modern armored bulldozers prove invaluable for route clearance, fortification construction, and urban operations where engineers must work under direct fire. These vehicles enable rapid terrain modification, essential for military operations, while protecting operators from enemy action. Mine layer tank. This specialized vehicle deploys anti-tank and anti-personnel mines, rapidly creating defensive barriers or protecting flanks during operations. Based on tank chassis, mine layers feature automated mine dispensing systems, enabling rapid battlefield obstacles. The German Panzerkampfwagen 3 AUSFE mine layer variant carried 96 mines deployed through rear-mounted chutes during World War II, though production remained extremely limited. The Soviet PMZ-4 mine layer, based on the ATP artillery tractor, could lay 400 mines, creating barriers quickly during defensive operations. The British Bar mine layer, towed by tanks, deployed anti-tank mines from reels, creating instant minefields during withdrawals. Modern systems like the German LAR's multiple launch rocket system can deliver AT-2 anti-tank mines by rocket, creating instant minefields at distances exceeding 40 kilometers. Rapid mine-laying capability proves essential for shaping battlefields, channeling enemy movements, and protecting defensive positions, though modern mine warfare remains controversial due to humanitarian concerns over indiscriminate weapons. If you enjoyed this video, don't forget to subscribe to this channel, like this video, and drop a comment. See you on the next one.